In this video, I want to show you how to construct a graph on Google Sheets. And the lab activity we're going to use for this example is the thickness of aluminum foil lab, where our students were provided with 5 aluminum foil squares, where they were able to measure the length and the width of these squares and determine the volume using the density of aluminum and the mass of each square. So what I'm going to do is I'm going to construct a graph where volume is represented in the y-axis and area is represented in the x-axis. And the slope of the trend line that results will give us the thickness of the aluminum foil, because the volume divided by the area is the height or thickness of the aluminum foil. So in order to construct this graph, I want to highlight the data that I want to use in the graph. So I like to just put my x-axis values as the first column and my y-axis values as the second column. And then what I'm going to do is I'm going to go and insert a chart, okay? And it'll automatically generate a graph for me. And here we go. So, and I don't want it to be a line chart. I actually want it to be a scatter chart. Okay. And you can see the data points. Now, Google Sheets was pretty nice here in that it took the cells above each of the data sets and use those to construct the graph. But you can go ahead and edit that if you wanted to change the name of the title of the graph, or if you wanted to change your axes, you can go ahead and click on that and change that. You can also see that it automatically set for us a range for each of the axes, and I'm going to show you how to go ahead and change those. But so first things first, I want your data to be in a scatter chart. And then what we're going to do is customize your graph, and I'm going to go to series. So customize and then series. And what I'm going to do is I'm going to check the box where it says trend line. And that'll automatically generate a line of best fit for me that I can use to establish the relationship between volume and area. But just having the trend line by itself doesn't really give us any quantitative information. I mean, you could go ahead and interpret this and do some calculations on your own, or you could take the easy way out, which is what I would recommend. And instead of having no label for your trend line, you're going to use the equation. Okay. And in this, the slope of the trend line, like we said, because, you know, the equation for a line is equal to y equals mx plus b. The y-intercept in this case, I don't really care about. What I'm really looking for is the slope, because that shows the relationship between the volume and the area. And what we get here, looking at the slope, this 1.86 e to the negative third is really 1.86 times 10 to the negative third, or we would say 0.00186. Okay, and that slope, again, is the thickness of aluminum foil. And that value makes sense. We're measuring all of these in centimeters. So eventually I would go in and I would add labels to these, like volume, and I would put centimeters cubed, area, I'd put centimeters squared. And what we would end up with for the slope would be a unit label of centimeters. And so the thickness of aluminum foil we could calculate here would be 0.00186 centimeters in thickness. Okay, hopefully that helped. What things to think about if it's not coming out like this for you right away, things that you could adjust. If you go into the setup, you can choose what your axes are represented by. You can select the data range. Make sure your x-axis is what you want it to be. So you select the cells that are represented in your x-axis. Sometimes it'll automatically, when it automatically generates the graph rather, it'll misinterpret what you want. So make sure that you have the appropriate cells in your x-axis as well as your y-axis. Yeah, hopefully that helps.